Assalamualaikum and hi, I'm Nur Alfidatunalira. So today I'm going to discuss about a question of a case study. So the question is, acetone is being absorbed by water in a packed towel having a cross-sectional area of 0.186 meter per square at 293 Kelvin and 101.32 kilopascal. The inlet air contains 2.6 mole percent acetone and outlet 0.5%. The gas flow is 13.65 kmol in air per hour. The pure water inlet flow is 45.36 kmol water per hour. Fluent coefficient for the given flows in the tower are K prime YA is equal to 3.78 times 10 to the power of negative 2 kmol per second m cube mole fraction, and K prime XA is equal to 6.16 times 10 to the power of negative 2 kilogram mole per second m cube mole fraction. Gradient for equilibrium line is 1.186. So the question asks us to calculate the tower height using K prime YA and calculate tower height using K prime XA, and the last one is to calculate the tower height using K capital prime YA. As soon as we get a question, it is really important for us to list out all the information given. So for this question, it's already given to us the value of A, the value of temperature, value of pressure, the value of K prime YA, K prime XA, and the gradient value for equilibrium line. So for the value of area is equal to 0.186 meter square, temperature is equal to 290 Kelvin, pressure is equal to 101.32 kilopascal, K prime YA is equal to 3.78 10 to the power of negative 2, K prime SA is equal to 6.6 10 to the power of negative 2, and the most important value is the gradient for equilibrium line, which is 1.186. Okay, so for the very first step to answer this question is we have to draw a diagram based on the question given. So for the diagram, we have two streams, which is gas stream and liquid stream. For the gas stream, we have inlet gas, outlet gas, and for the liquid, we have inlet liquid and outlet liquid. So for the inlet gas, we write it down as V1 and V2 as the outlet gas. So for the inlet liquid, we write it as L2, and for the outlet liquid, we write it as L1. So the composition will be like Y1 for the inlet gas, Y2 for the outlet gas, X2 for the inlet liquid, and X1 for the outlet liquid. So next, the question is already given to us the value of the gradient for equilibrium line, which is 1.186. So the value is, we have to use it to develop the relation between the equilibrium line, which is YA is equal to MXA. So it's stated here that SA is equal to 0.0333 and YA is equal to 0.0395. So this birth value, we can get it from the appendix A.3 for acetone. So after we substitute this birth value, we get it that the relation is YA is equal to 1.186 XA. So after we got this relation, we can find the value XA by substitute the value YA. So the value of YA, we can find it in this graph. So after we substitute in this relation, so we can get that SA is equal to 0 and SA is equal to 0.0253. So after we already get the relation, which is YA is equal to 1.186 XA, so we can create a table between Y and X, which is when the Y is equal to 0, X equal to 0. So when the YE is equal to 0.030, the XA will be 0.0253. So when we get these two coordinates, we can create the equilibrium line. So I will show the equilibrium line in the graph after this. So after we already plot the equilibrium line, we have to plot the operating line, which is we have to we have to obtain two coordinate, which is P1 and P2. For P1, we have to get the value of x1 and y1. For P2, x2, y2. So I will show how these two lines will looks like. So this is the graph. Okay, so this is the graph, which is this equilibrium line, and this is operating line. So the equilibrium line, which is we already get it on the table for y8 and xa, which is 0, 0 and 0.0253, and for the ya is equal to 0.030. So we move to how to create the operating line. For the operating line, we have to find two coordinates, which is x1, y1, x2, y2. So in order to find the value of x1, y1, x2, y2, we have to check in the question. So y1, x2, and y2 is already given in the question, which is 0.026, 0, and 0.005. So but the value of x1 is not stated in the question. So in order to find the x1, we have to use the mass. We have to use the overall material balance, which is L prime times by x2 divided by y minus x2 plus v1 times by y1 divided by 1 minus y1 is equal to L prime times by x1 divided by 1 minus x1 plus v prime is equal times by y2 divided by 1 minus y2. So after we have to check the equation. So we already know the value of x2, which is stated in the equation, which is x2 is equal to 0. For v1 is already in the equation, which is 13.65 here. So for the L1, as we use liquid in it, the value of L1 is equal to L prime, which is 45.36 kilomole per hour. So after that, for the value of y2 is already stated in equation, same goes to the value of y1. So the only unknown here is x1. So we have to substitute all the value given and all the value we already know in this equation. So after we calculate it, we get the x1 is equal to 0.006479. So we can use it as a coordinate, which is x1, y1. So 0.006479 and 0.0026 for y1. So for x2, y2 is 0.005. So after we get these two coordinates, so we can already plot the line, the operating line, which is will be like here. This is the operating line, which is for the P1 is 0.006479, and for the y2 is equal to 0.026, and for the second coordinate, which is 0 and 0.005. So this is how we plot the operating line and the equilibrium line. Next, we move to the next step, which is we have to find the slope by using equation of slope of peak absorption column. So this is the quick equation, which is negative k prime xa divided by 1 minus x1 divided by k prime ya divided by 1 minus y1. So the value of k prime xa and the value of k prime ya is already stated in the equation before. So for the value x1 and y1, we can get it from the graph, which is we already got it in the step previously. So after we substitute the value, we will get the slope is equal to negative 1.6. So the next step, we have to find the value xi1 and yi1, which is we use this both value in the equation after this. So in order to find it, we have to find the value of y-intercept first. So we use the relation, which is y is equal to mx plus c. Y we already know in the graph, and for the m we use this value, and for the x we already know from the graph before. So after we calculate it, we get the c is equal to 0.0364. Actually, the exact equation or the original equation to find the slope for PM1 is this, which is negative k prime xa divided by 1 minus s high m divided by k prime ya divided by 1 minus yin. So, but in this formula, it is already stated that we have to find the value sim and yin first in order to use this equation. So that's why we use this first equation to get the value si1 and yiy. So I will show to you guys how to find the value of si1 and yi1 in the graph. So we already know that the y-intercept is equal to 0.0364. So we have to drag this point to the operating line, and we have to use the same slope to drag it to the equilibrium line. So after it touches the equilibrium line, we will get this intercept. So the intercept, we have to drag it to the x-axis to get the si1 value, which is 0.013, and drag it to the y-axis and get the yi1, which is 0.015. So that is how we get the value of si1 and yi1. So back to the equation, the origin equation. So after we substitute the value, which is in here, in order to find the value 1 minus yin and 1 minus sin, we have to calculate it first. So the one yi1 and y1, we already know the value, which is y1 from the questions and yi1 from the graph. Same goes to the 1 minus sin part, which is si1 from the graph and x1 from the question. So after we substitute the value of 0.979 and 0.9901, we will get the slope of PM1 using the original equation is negative 1.62. As the value of PM1 using second trial and first trial is so close, so we can consider it as accurate enough. We move to the next step, which is to develop the second slope of the graph to get the PM2 line. So we have to get the coordinate for PM2 first. In order to get the PM2 coordinate, we can use this relation, which is y is equal to mx plus c. So for the y, we use as 0.005. For the m, we use the m before that we get from the PM1 line, and x 0. So plus c, and we get the y-intercept is equal to 0.005. So after we substitute in this relation, we will get the x equal to 0.003. The y is equal to 0 because of, wait, I show you guys the graph first. So this is the graph. So from the y-intercept, which is 0.005, we drag it where the y is land on it, where the y land is 0. So we will get the x is equal to 0.003. After we found out that the coordinate is 0.003 and 0, so we can get the value of xi2 and yi2, which is the intercept between this line and the equilibrium line. We will get the xi2 and yi2, which is xi2 is equal to 0.0081 and yi2 is equal to 0.0022. Okay, this is how we get the value of xi2 and yi2. So we move to the very first question, which is it has asked us to calculate height tower using k prime ya. So to using k prime ya, this is the equation, which is v average times by y1 minus y2 is equal to k prime y is x times by y minus yin. So based in this equation, we already know the value of y1 and y2. We already know the value of k prime y and a. So the only unknown in this equation is y minus yin, z, and v average. So we need to find this value, which is z for the height. So for the v average, we can find it by using this formula. V average is equal to v1 plus v2 divided by 2. So this is how we use This is how we can get the V1 and V2. V1 by minus by 1 minus Y1. So V2, V1 minus Y1 minus Y2. So after we calculate the value of V1 and V2, so we plus it both and we divide by 2. So we will get the V average. So for the 1 minus YIM, so this is the equation to get 1 Y minus YIM. So for Y1 it's already stated in this question. So YI1 we will get it from the graph. Same goes to the YI2 where we can get it from the graph. So after we substitute the value that we already know, either from the graph or the question, we will get the value of Y minus YIM is equal to 0.006. Okay, for now, the only unknown value is z, which is the height. So after we substitute all the value, which is 0.00385, 0.0026 minus 0005, so after we substitute all the value, we will get the z is equal to 1 minus 946 meter. So this is the height of tower using K prime YA. For the B part, the question asks us to calculate the tower height using K prime XA, which is the equation reversed like this, which is L average equal to L average times by x1 minus x2 is equal to K prime XA z times by xi minus xm. So the unknown value here is L average, xi minus xm, while the K prime x and a x1 minus x2 is already given in the question. So for the L average, you already know that the liquid is inert, so L1 is equal to L prime is equal to L2, so L average is equal to 45.36. We divide it by 3600 to change it to the SI unit for the time. So SI minus XM, we can use this formula, which is XI1 and XI2. We can get it from the graph, and X1 and X2 is already stated in the question, or we already know the value before. So after we substitute, we will get the SI minus XM is equal to 0.003. So after we already know all the value, which is L average is equal to 0.0126, x1 minus x2 is equal to 0.006479 minus 0, K prime x equal to 6.16 10 to the power of negative 2, error is 0.186, and SI minus SM is equal to 0.003627. The only unknown here is Z, which is the height. So the height is 1.964 after we calculate it. So that's the height of tower using K prime XA. Similar to the next part, which is the question asks us to calculate tower height using K capital YA. So compared to the question before, the coefficient is already given, which is K prime YA and K prime SA. But for the K capital prime YA is not given in the question. So we have to find first K capital YA. So this is the equation for the K capital YA. This is the question, which is 1 divided by K prime YA divided by Y minus Y star M is equal to 1 divided by K prime YA divided by 1 minus YIM plus M prime divided by K prime XA divided by 1 minus XIM. So for the M value, we have to use the gradient for equilibrium line, which is 1.186, which is that stated already in the question. So for the 1 minus IM, 1 minus SIM, K prime XA, K prime YA is already given in the question. So for the value for the 1 minus Y star M, we have to find it first in order to get the K capital YA. So this formula is here. 1 minus YI star minus 1 minus Y1 divided by ln or times by 1 minus 1 star divided by 1 minus Y1. So the value of Y1 is already given in the question. But the only problem here is we don't know the value of yi1. So in order to get the value yi1, we can find it in the graph. So how to find the value of y1 star and y2 star, where the y2 star we will use in the equation after this. So to find the yi1 star, it is like this, where we have to drag the value of P1 and P2 to the equilibrium line. So this is P1, we drag it to the equilibrium line and we move to the y-axis. So this is the y1 value, which is in here we can see that the y1 value is equal to 0.007, and for the y2 that we get from the using P2 line and drag it to the equilibrium line, we get that y2 is equal to 0. So this is how we can, that is how we, that is how the method to get the value of y1 star and y2 star. So back to the equation. So we substitute the value of y1 star and y minus y1. So the we will get the answer is 0.983. So after we will get the value of 1 minus y star m. So we substitute in this equation and the only unknown here is k capital YA. So after we calculate it using basic mathematics, so we get that k capital YA is equal to 0.02183. There is no final answer as the question asks us to calculate tower height, which is z, it's not k capital YA. Capital YA is the only coefficient. So, in order to get the k capital YA, the equation is k capital YA is already we already got it. So, in order to find the value of z, this is the equation, which is v average equal to times by y1 minus y2 is equal to k prime y a z divided times by y minus y star m. So we have to calculate the y minus y star m first. So after we calculate it, after we substitute the value that we already got from the graph or the equation, which is y1 from the equation, y1 star from the graph before, y2 from the question, and y2 star from the graph before, which is the value is 0. So we will get that y minus y star m is equal to 0.01028. So we substitute in this value, which is the average we already known before. y1 and y1 minus y2 also we already know before. K capital prime y is already known before, which is we calculate it here. So A is the area. So y minus y star m, we substitute this value. And we will get that z is equal to 1 minus 937. So this is the final answer for C part. So that is the end of the question where we will already calculate our height using k prime ya, k prime sa, and k capital ya. So that is how the method and the way to calculate the height of the packed tower column. So it is a bit difficult, but if we practice more, we can easily tackle the question. So that is all from me, from the Afriatina Dira binti Muhammad Rafi'i. And thank you for hearing this.